morning, geometry. It's a very sunny summer day here, and the sun is setting, so I'm kind of blinded. But I thought we would do a lesson on the Pythagorean Theorem. It's kind of a classic. Um, One thing I love about it is it involves Pythagoras, and I think he is just a crazy dude. Pythagoras, if you don't know about him, he's an ancient Greek, and he was a wonderful mathematician. But even more than that, more than just being able to do math, he actually almost like worshipped numbers. He had a whole following, a cult that followed him, and they believed that numbers were mystical and that they were actually tied to reality. He believed that, for instance, like all odd numbers were masculine, all even numbers were feminine. He believed certain numbers had different properties. He thought three was kind of a very special number because it had a beginning, middle, and end. He really liked the number 10. He called it the perfect number because, can you see this? Because you can do this shape with it. You put four dots, and then in between those come three. And you've probably discovered this even just like doodling on your paper. But he loved that shape. He was obsessed with it. And so, because there's 10 dots in this shape, that's the perfect number for him. He called it the perfect number, number 10. Um, anyway, lots of different beliefs. He had some crazy ones. He forbade his followers to eat beans. They were evil. And in fact, when Pythagoras got killed, he was being chased by some people. And now, this is history, so you never know what story to believe. But one of the stories goes that he was being chased by people, but he got to a field of beans and he refused to run through it because it would have violated his beliefs, and then they caught him and killed him. He was big into numbers, except he did not like a certain type of number, the irrational number. In fact, they believed that they didn't exist. So any number that cannot be written as a fraction, or the way that we kind of talk about it a lot of times is it goes on forever. He just refused to believe that. And when one of his followers used Pythagoras' own theorem and had a triangle of one side with one and another side with one, and so then you get a hypotenuse of two, and if you take the square root of two, that's an irrational number. And when he discovered that, they killed him. So anyway, Pythagoras, crazy dude, lots of cool stuff. Another thing that stands out is supposedly he was very good at like self-control. So he was always cheerful, but he never laughed. I don't know, things like that. One time he went down to the basement of his house and he stayed there for 40 days. And he said he was going to the underworld. And when he came back up, he told his followers everything that they did during those 40 days. And they believed that he actually was in the underworld because he could see what was happening. So anyway, the Pythagorean Theorem, like I said, is a classic, and I'm sure you learned it in algebra. It involves right triangles. And if we call one of the legs A, we call one of the legs B, and we call the hypotenuse C. The hypotenuse is always the longest side, and it's always the one opposite of the right angle also. You can tell it two different ways. But the Pythagorean theorem simply says a squared plus b squared equals c squared. And so you can solve for any of these. If you know the hypotenuse and a leg, you can solve for the other leg. Or if you know two legs, you can solve for the hypotenuse. You can use this also to see if something is a right triangle. Like if I said, okay, I'm going to give you one leg that's 3 and one leg that's 6, and the hypotenuse is 7. Well, you can just see, is 3 squared plus 6 squared, does that actually equal 7 squared? So this is 9 plus 36 does not equal 49. So you know that is not a right triangle. Furthermore, I think it's, where is it back here? It's theorem 8-6. It says if these two add up to more than this, so in this case, actually, they add up to less. So let's just do that. If these two add up to less than the hypotenuse squared, think what that means. It means that this and this are not long enough to equal that. So that gives you an acute triangle. If the two legs add up to more than the hypotenuse squared, that means they're actually out, they're longer, then that's going to give you an obtuse triangle. Okay? So those are pretty simple theorems. Again, that's 8.6 and 8.7. And then I would say the last thing that's kind of handy to know are what are called Pythagorean triples. Some classic ones would be like 3, 4, 5. That's the classic. 3 squared, if one of the legs was 3, one of the legs was 4, and the hypotenuse is 5, you can quickly tell that 9 plus 16 is 25. That equals 5 squared. Okay? So a 3, 4, 5 is a right triangle. And, you know, I used to work with guys, work construction, and I swear these guys, you know, they probably hardly graduated high school. They definitely weren't mathematicians. But even they might not even actually have known what Pythagorean theorem, what the name was called. But they used the Pythagorean theorem every day. When we would build a wall, you want it to be at a 90-degree angle, right? You want it to stand up at a 90-degree angle. So on the deck, you know, here's your deck of your house, and you would lay down the boards that you wanted to be at a 90-degree angle. And all that they would do, so to make this clear, there's like a 2x4 there, and there's a 2x4 there. All that they would do is they would measure out this way 3 feet. And they would measure out this way 4 feet. And then we would just hold the tape measure right there, and we would extend the tape measure out and adjust this until, what do you think we wanted this distance to be? We wanted that to be 5 feet. And when it was 5 feet, you knew that this was a right angle. Does that make sense? So again, these guys, you know, they didn't know their head from a hole in the ground. They had really no formal education, but they knew how to use the Pythagorean theorem. Okay, pretty smart. Another Pythagorean triple. So what do we have? We have a 3, 4, 5. Another one that I know off the top of my head is a 5, 12, 13. And the book gives you a couple more that I honestly did not know these. And I have to kind of remind myself what they are. They give you an 8, 15, 17. I didn't know that one. And they also give you a 7, 24, 25. Okay? So if you have sides of a triangle that are these numbers, they're going to be right triangle. And of course, if you double these, so a 3, 4, 5 would be a right triangle, so would a 6, 8, 10. Does that make sense? Or triple them, or whatever proportion. Okay, I think that is it. Pythagoras, cool dude. Look him up. Love him. And the Pythagorean theorem, very useful. It's useful in math. It's useful in real life. And you should be able to use it to do a lot of different things.